Okay, so this is the second video on chain rule, and in this video I'm going to go over some examples that are going to mix some of the rules that we've already learned. We are still following the same rule. Take the derivative of the outside, leaving the inside alone, times the derivative of the inside. But what we're going to do now is notice that let's just look at this function. And I noticed that there's a function, 7x, inside of the cotangent, but I also noticed that there's a 5x cubed on the outside. Well, there's really not an outside and an inside between the cotangent and the 5x cubed. It's really a multiplication problem, a product. And so I have the product of 5x cubed and cotangent, but there is a 7x inside of the cotangent. So what's going to happen here is that I have really a product rule to set up. If I have a product, I have to take the derivative using product rule. So I'm going to go ahead and set up my u, which is going to be 5x cubed. And then my u prime is going to be 15x squared. Okay. And my v is the second function, which is cotangent of 7x. And this is where the chain rule is going to appear, because in order to take the derivative of v, cotangent 7x, I'm going to have to use chain rule because I have a function, 7x, inside of another function, cotangent. So the derivative of the outside is going to be negative, starts with a c, so it's negative, cosecant squared of, leaving the inside alone, 7x. But I now have to multiply by the derivative of the inside, which is 7x. So the derivative of that is 7. And again, we're just going to make this a little pretty. Negative 7x cosecant squared of 7x. All right, now that's just, so what's happened is we've set up the product rule, and the chain rule came into play because I needed to be able to take the derivative of cotangent of 7x. See, that's how I got that that's where the chain rule came into play. So let's go ahead and run the product rule. And that's going to say it's u times v prime, so that'll be 5x cubed times negative 7 cosecant squared 7x. So it's going to be negative 35 x cubed cosecant squared of 7x plus, and now we're going to multiply the v and the u prime, 15 x squared cotangent of 7x. And that's it. There's really no more simplifying. We're done. Okay, so we have a next example here. And you're going to notice that now instead of a product I have a quotient, and because I have a quotient I'm going to set this up with quotient rule. U is going to be 8x minus 1. U prime is no chain rule required here, it's just straight up derivative, gives me 8. And then V is going to be, and this is where the chain rule is going to be making its appearance, because you see I have a function 2x minus 4 inside of another function which is to the power of 5, and to take the derivative of that function I'm going to use chain rule. I'm going to take the derivative of the outside, which is the 5th power, so that would mean bring the power to the front and then subtract 1, so that's 4, leaving the inside alone. So I copy it the same. But then I multiply by the derivative of that inside, which in this case is 2. And making it prettier, 5 times 2 is 10 times 2x minus 4 to the 4th power. And now we're going to go ahead and set up the quotient rule. Whoops, let me undo that guy. Okay. So now we're going to go ahead and do, it's going to be v times u prime. So the derivative is going to be 8 times 2x minus 4 to the 5th power, and I'm going to subtract u times v prime. So I have, technically I'll put the 10 first because the order doesn't really matter since it's multiplication. I'll put 10 times the quantity 8x minus 1 times the quantity 2x minus 4 to the 4th power. And then we're going to divide that by 2x minus 4 to the 5th power, but it gets squared, so that 5th power becomes a 10th power. Okay? Now, if we were going to simplify this, we could factor out 2x minus 4 to the 4th power from both of these, and it would cancel out with this one here on the bottom. So it would look something like this. So if I were to factor 2x minus 4 to the 4th power out of both of these, it would leave me one of them here, 2x minus 4, and I would have none of these left over. So that's why I just have 10 times the quantity 8x minus 1. The 2x minus 4 to the 4th power would reduce with this 10, making it a 6. And so this would be sort of the next step. Then I would distribute, and you do not have to do this, but just in case this is a multiple choice question and it's really simplified, I'm just kind of showing you how that would work. And as you can see, I distribute, combine like terms, and I believe this is what it comes out to. So you might see this all simplified as a multiple choice answer, but this derivative is the same exact thing as this, so they're both correct. It's just one is more simplified. Okay, this last example I'm going to go over is really the same problem that I introduced in video 1 when I showed you the kind of an example of a composite function. And so that's really what we're going to go ahead and take the derivative. I want you to notice that if we rewrite this, and I encourage you to rewrite it when there's a trig function with the exponent here, what that really means is that we have a cosine with a 4x minus 1. So right here we have a 4x minus 1 inside of a cosine. So already that's a composite. But in addition to that, the whole thing is being raised to the 2nd power. So you have yourself 3 layers here. You have the very inside, which is 4x minus 1. You have the cosine, and then you have the squared. Alright, so how does this work? Because there are 3 layers, you're just going to start to kind of peel at it like an onion from the outside in. So you're going to apply the chain rule, and let's get started with that. We're going to take the derivative of the outside. Well, the most outside function we have is the squared, which means we're going to bring the power down. So that'll give us a 2 times cosine of 4x minus 1. And technically we're going to subtract 1, so that's to the 1 power. And then we're going to multiply by the derivative of the inside. Well, the inside is cosine of 4x minus 1. So in order to take the derivative of that function, you're going to need to apply chain rule one more time. So the derivative of the outside becomes negative sine, leaving the inside alone, times the derivative of the inside, 4x minus 1, which is 4. So we have here 3 layers. We started with the derivative of the very outside, which was the squared part. That's how we got this 2. And then we have a 1 left over for the power, leaving the inside alone, times the derivative of the inside, which is cosine. So that's negative sine. But because it's another composite, we had to then take the derivative of the inside one more time. So we essentially had to apply chain rule twice. Making this pretty would be the derivative of p of x. It's all multiplication, so I'm going to have the 4, the negative, and the 2. So it would be negative 8. And I have cosine of 4x minus 1, and I'm not going to write the power of 1, it's not needed. But I am going to include that sign of 4x minus 1. So here's an example where you had to apply the chain rule twice because there was really 3 layers instead of just one. Okay, so go ahead and try out the problems assigned, and we'll check them out tomorrow.